This is a question that covers bonding. It also has atomic structure and redox within there. There are 14 marks in total, and it does include a 6 marker. So take a look through each section, try it, pausing as you go, and then review your answers. Here's part A, part B, C and D, part E, and finally F and G. So let's take a look at part A, where you're being asked to write the electron configuration for an iodine atom. Now, you only have to actually learn these up to krypton, but there is an expectation you can apply that knowledge. So I am going to add the little aide-memoire that might be useful to you, because if you write out your 1s, 2s, etc. in the triangle that we have up at the top, you can then work your way through. So we go 1s, 2s, 2 3s, 3p, 4s, 3d, 4p, 5s, etc. And krypton takes us as far as 4p6. Now I know that I'm going to go to 5s next, that has 2 more. Then I'm going to fill my 4d10, and I've got 5 left to go in 5p5. And actually there's another way that we can check this, because we can look at the remainder of group 7 that all end in P5, and that's just a very quick check for you. Moving on to the 6 marker, as always I'm going to provide the marking criteria, and we have those here, and let's take a look through. There are 3 stages. In stage 1 you need to mention that both I2 and HI are molecularly covalent. To access stage 2 marks, you need to say that they are both held together by intermolecular forces, that these are weak and therefore there are low melting points, but the I2 molecule is bigger than HI, so there are more electrons. Now for that reason, that means there are stronger van der Waals forces in I2 as we enter stage 3. And that means more energy is needed to overcome them. But you might also be thinking that the HI has dipole-dipole bonding. This is true and should be mentioned, but in this circumstance the dipole-dipole bonds are not as strong as the van der Waals forces in I2. Going to move on to part C. Why iodine does not conduct electricity? Very straightforward, it has no delocalized electrons. For the equation forming hydrogen iodide from its elements, we're told that it's HI, and we know that anyway. H is +1 and I is -1. You have got to remember that hydrogen and iodine exist as diatomic elements, and then you need to balance it. When we move on to part E, we are given quite a lot of information here that we need to work through to fully understand what we're looking at. And triiodide ion is an iodine molecule bonded to an iodide ion. Now we know that an iodine molecule has no charge, and an iodide ion has a -1. So the I3- you would be expected to recognise would be a -1 charge. You also need to know that NH4 has a +1 charge. Now if I put those together, and I'll use the seesaw, this is now balanced. 1 NH4 plus, 1 I3-, and that means the correct answer is NH4I3. Moving on to F, the shape of the IF3 molecule. Well, I've done a little dot cross diagram just to help me out here, and I can see that I have got 3 bonding pairs and 2 lone pairs, so it's based on trigonal bipyramidal. If I do the IF4-, I see that I've got 4 bonding pairs and 2 lone pairs, so that means it's based on octahedral. And don't forget to include the square brackets and the negative charge around it, because it is charged. And then deducing the oxidation state of iodine in the following species, BaIO32, well, we know that Ba is +2, so each IO3 is a -1. Within that IO3-, the oxygens contribute -6, so the iodine has an oxidation state of +5. On the H4IO6- ion, my 4 hydrogens are +1 each, so that's +4. My 6 oxygens are -2 each, so that's -12. And that means that when I can work out the remainder, the iodine to take us up to -1 is +7.